Does it ever feel like you're a marketing professional just speaking into the void? But with LinkedIn ads, you can know you're reaching the right decision makers, a network of 130 million of them, in fact. You can even target buyers by job title, industry, company, seniority, skills, and did I say job title? See how you can avoid the void and reach the right buyers with LinkedIn ads. Spend $250 on your first campaign and get a free $250 credit for the next one. Get started at linkedin.com/campaign. Terms and conditions apply.
This episode is brought to you by Nespresso. Gift magical mornings with Nespresso Virtuo Pop. Compact and stylish, Virtuo Pop is made to meet every morning coffee craving. From espresso to coffee, hot or iced, at the click of a button. And celebrate the season with Nespresso's limited edition coffee flavors. Sweet almond and hibiscus, cinnamon and candied tamarind, and festive double espresso. Magic in the making. Shop the holiday gift collection exclusively at Nespresso.com.
2025 is coming to an end. So for this From the Theatre episode, we're exploring some of the most exciting science to look out for next year. But instead of bringing you content from our own theatre, I've come to a place where I can speak to lots of researchers and science communicators all at the leading edge of their field in the same place. So we're bringing this episode to you from the Excel at New Scientist Live 2025. I'm going to see who I can chat to on the stands here in the main exhibition hall, then head up to the press and speakers room to catch some of today's speakers between their talks and ask them what research they're keeping an eye on for 2026.
I'm Dr. Yasmin Mida, I'm from Cranfield University, and I'm at the stand called EBIC, which stands for Environmental Biotechnology Innovation Centre. What we do at EBIC is a consortium of 10 different universities across the UK, and we are using microbes to clean up the environment, whether that's wastewater or drinking water, and we are using synthetic biology to do so. So that is genetically modifying our organisms to increase their potential of biodegrading different pollutants or removing microplastics. It can even be to do with resource recovery, so we have phosphorus and nitrates that are a finite resource in the environment, and we could potentially use these bacteria to take up these nutrients and then recycle them for fertilizer in crops. And one thing that I'm really excited about for the future of this research is actually being able to use microbes that you can genetically engineer, and that's not a bad thing to say. It's that we can use this for good and really clean up the environment and stop putting other chemicals in our environment and getting toxic waste products. And so I think the potential for this is absolutely huge, and the really big challenge is to get this at scale and into water treatment. But hopefully within EBIC we're going to achieve that within the next 5 years of our research grant that we're on.
So people who come by the EBIC stand today, what would be, if you could have one key takeaway that you'd like for them to remember about you guys, what would it be?
Is that genetic modification or GMO isn't bad. It can be bad in some aspects, but what we're doing is really enhancing the natural microbial populations within our system. There's microbes absolutely everywhere, and some of them are good. So please remember that not all bacteria are bad, and there are some really good ones.
Fantastic, thank you so much. I managed to catch the first wave of speakers coming back from their talks up in the press room. With the nerves of stepping up onto their respective stages fading, I took it as my chance to swoop in and ask them about next year's upcoming science.
So my name's John Butterworth. I'm a professor at UCL. I do particle physics. I work at CERN on the Large Hadron Collider. So I was talking a little bit about, just over 10 years ago now when we discovered the Higgs. So I was kind of trying to fill people in on what we've been doing since, really.
And what was your favourite scientific innovation or piece of research that you came across this year in 2025? It can be your own or someone else's.
Well, it's biased towards my own. It doesn't mean this. I may have forgotten another one, but one that I mentioned in my talk actually is the most recent exciting thing from the LHC, which is the top quarks form a very brief bound state, which what that means, so the top quark is the heaviest of the quarks. Most quarks live all the time inside hadrons, so like the proton is made of quarks and the neutron. The top quark is so heavy that everyone thought it decayed so quickly that it didn't have time to form a kind of top anti-top bound state, but actually there are signs that one does exist very briefly. And when we create two top quarks at the Large Hadron Collider, and they're only just enough energy to make them, so they're not moving very quickly, they're almost at rest, then it looks like they do form very briefly a bound state, which is a big surprise. It's not beyond the standard model or anything, but it's a really new phenomenon in the standard model that we've not seen before. So that was the highlight for me.
And then either at the LHC or elsewhere in your field, is there a piece of research or science that you're really excited to see develop in the next year or so, one for people to keep an eye out for?
Okay. I'm going to give two, if that's all right. So one of them is not really science, but it will be the future of science. So at the moment, there's a big discussion going on about what the European strategy for particle physics should be, which will influence what comes after the Large Hadron Collider, which is a long time in the future, but these things take a long time. So I'm very excited to see what we come up with there. And obviously CERN is the world-leading place to do this. So while this is only a European strategy, it's going to basically determine what the human race does at the energy frontier for the foreseeable future. So it's kind of exciting. And then more kind of further away, but closer in time, there's a new experiment just switched on in China, in the south of China, called Juno, which is measuring neutrinos from a bunch of power stations nearby, nuclear power stations, which should be able to make some really precise measurements of the neutrino, which is not my subfield of particle physics, but is really exciting and really interesting. And it's also really interesting because this is the biggest experiment that China's ever done, and they're doing more and more in particle physics. And I was there recently over the summer, and it's also very exciting to see that developing in general. And the Juno is the biggest, most ambitious thing that they've done so far, and it's going to be very cool. And it's started taking data, so that hopefully this year we'll get some results from that.
So my name is Ciara Green.
My name is Gillian Murphy.
We are cognitive psychologists, and our talk was about memory. It was called The Perfectly Imperfect Ways We Remember. And our work is really all about memory reconstruction and all the ways that our memories might be distorted, but that they evolved that way for a reason.
What was your favourite scientific innovation or piece of research that you came across in the year just gone, in 2025?
Slightly unrelated to the topic that we were speaking about today. I do a lot of research on deepfake technology. These are AI-generated forms of media that can let you depict a person saying or doing something that they might never have done. And one of the avenues that we've been looking at, so part of it is memory work, looking at how deepfakes can distort your memory. But one of my PhD students, John Toomey, has also been developing evidence-led tools to try to combat deepfake abuse, which is typically making non-consensual pornography, mostly of celebrities, almost all of women. They're surprisingly, when you look at the statistics, around 96% of deepfakes on the internet are that kind of content, but there have been no interventions developed to try to deter people from making that kind of content. There's increased efforts from a legal perspective to prosecute people after the fact, increasing pressure on platforms to take them down. But we've, I suppose, come to that same problem from a psychological perspective and designed this incredibly simple, low-hanging fruit kind of intervention that just educates people about what deepfakes are, why deepfake abuse is harmful, and then in hopefully a non-paternalistic way, encourages people to just connect with their own values and whether consuming, sharing, creating that kind of content is something they want to do if they think if they kind of focus on empathy with the victim. And it really works. And we follow people up weeks afterwards, and they don't believe the myths about deepfakes anymore, and they have reduced intention to consume that kind of media. So that was my favourite one, very close to home with one of my students, but I think it's really exciting.
Yeah, so I suppose we've been doing a lot of work lately about fake news and what the kind of things that affect how people will fall for fake news. And we've been doing a lot of work looking at emotion, and particularly with one of my students, Aphrodite Asimakapulu, has been doing a lot of work looking at how emotional fake news and people's own emotions interact to make us more or less susceptible to misinformation. And it's been really interesting because we had assumed that people's own emotional state would play a big role, but actually we find it doesn't. And really all that matters is if the content that you're looking at is in itself emotional, then that really tends to drive the kind of people's tendency to believe in misinformation, and also to kind of form false memories for it, all of that. And we're looking at that now in the context of like food misinformation. So, like, which is a really kind of growing area. There's a lot of misinformation out there about, say, new kind of like plant-based alternatives to meat, things like that. So we're looking at a lot of work like that and finding some really interesting stuff there.
What would you say is the piece of scientific research that you're looking forward to the most and seeing how it progresses next year in 2026?
I think the one that I'm most interested in at the moment is we have a new project that we're actually looking at doing EEG, electroencephalography analysis of the misinformation effect. So that's if somebody is an eyewitness to a crime and then they're exposed to post-event misinformation later. So let's say you witness a car crash and then someone says to you, how fast was the car going when it sped through the red light? And later you remember that the car was going fast and that it went through a red light, even though that might not have been in the original stimulus that you saw. So that we've done lots and lots and lots of work. Gillian and I have done lots of work on this over the years. It's kind of a big field, but there's a few different kind of theoretical models about what's happening when we are exposed to this misinformation, and we're kind of at a bit of a point now where in order to progress this, we're going to look at some EEG data and see how some of this misinformation is processed in the brain. And so mostly, Gillian and I would say that for most of our work, brain data, EEG, fMRI, isn't the appropriate level of analysis. The appropriate level of analysis is behavioural. But for this question, to proceed, to progress it to the next step, that's kind of where we're going to go. And we think that's going to help us kind of break a tie in a couple of theoretical questions.
It's very convincing.
Thanks.
Yeah, we're both just talking about our own projects here. I'm conscious of we could just talk about other people, but what I am excited to do next year is it's starting in January. I got a big European Research Council grant, which will run for 5 years, and the intention is to paradigmatically shift what the thinking is in your field. So it has to be ambitious. It has to be something that could really change the way we think about whatever the topic is. So mine is about false memories, which is what our talk was about today, and that we have a book about. It's called Memory Lane, and as Ciara said, it's about the perfectly imperfect ways we remember. And in that book we talk about lots of different ways, I suppose, of thinking about memory errors, quote unquote, and whether or not they might really be errors, and whether or not having a malleable memory might be a failure of evolution, like some people think it is in certain contexts, or whether they evolved that way for exactly a good reason. And there has been kind of growing understanding in our field as to why we evolved to forget things, partly because we've identified a group of people that have real trouble forgetting things, and we see the negative effects it has for them. On the surface, it seems great. They remember every day of their lives and it seems fantastic. And then you look a bit closer and you see, they can't move on from romantic breakups. They struggle to process information and give an answer quickly because they've just got this deluge of stuff kind of coming back to them when they try to recall. And so in looking at that counterexample, we start to understand why we evolved to forget. But in false memories, which is where Ciara and I do a lot of work, we don't have a counterexample, because everyone forms false memories, absolutely everyone. Like Ciara talked about with the misinformation effect, all the way up to much bigger studies where you can plant entirely false memories of childhood events in people, where we're all susceptible to this. And so my big proposal in this big project that I'm going to do is trying to find experimental evidence for those adaptive benefits for forming false memories. And so I have two main pillars that I'm going to look at. One is that they might help kind of sustain our well-being, that just makes us happier if we can build false memories that kind of serve this kind of well-being enhancing function. And then the other is that it might help to sustain our social relationships. So the example Ciara just gave about witnessing a car crash, one of the ways you can kind of contaminate someone's memory is to have them speak to a co-witness, kind of like you said. And we know if we have two people talk to each other and we can manipulate it so they actually both saw different events. And then if you have them talk to each other afterwards, they'll mess up each other's memories. And from a legal perspective, that's really bad. And typically that's where the experiment ends. But I'll be doing kind of longer experiments where I might see, okay, their memories are messed up, but what else might have happened? Maybe we're more empathetic towards each other. Maybe we're more willing to work together because we now have the shared understanding of what happened, and you can imagine the adaptive kind of benefits of that. So I'm excited. It's going to take years, but I will start next year, which is exciting.
Don't chew on that, Max.
Cooper loves that chew too.
Oh, now he's into Cooper's food. Wow, he is loving it. What do you feed Cooper?
Blue Buffalo Life Protection Formula. He never leaves a crumb. I love it because it's made with high-quality protein, nutrient-rich fruits and veggies, and wholesome whole grains.
Looks like we're switching to Blue.
Blue Buffalo foods are made with the superior ingredients your dog needs to thrive. Can your dog food say that? Visit feedbluefood.com to learn more.
This episode is brought to you by Nature's Bounty. Nature's Bounty believes your body is brilliant, naturally designed to thrive, inside and out. For those always looking for new ways to support your health from head to heels, Nature's Bounty has a range of over 400 vitamins and supplements born from 50 years of trust and care. Nature's Bounty. It's in your nature. Visit naturesbounty.com to learn more.
My name is Jaap de Rood. I am a professor at Emory University in Atlanta in the United States. And my talk was about how animals use medicine and what we can learn from them. And a lot of this is based on my own research on monarch butterflies and their parasites and how they use toxic milkweeds as a form of medicine.
What was your favourite scientific innovation or piece of research that you came across this year?
What I was talking about is really animals using medicines, using drugs. So using things that they collect from the environment, other animals or plants or fungi, and use that as medicine. But since I wrote the book on which the talk was based, there have been a lot of new cool things. And this year there was a really cool paper showing that ants can use amputations as well. They can use surgery. And that's really kind of the first animal outside humans that we now know does surgery. And what happens is that when there are infections in the legs of other workers, then the workers will cut off that leg basically at the base, and that stops the spread of the fungal pathogen, the fungal disease. So it's just mind-blowing to me because what it's showing is that animals are not just good at using medicines, drugs that we thought was something uniquely human, but now they can also use surgery. It's pretty exciting.
And looking forward, what piece of research are you most excited to follow up on next year?
So I think right now a lot of the cases that we have of knowing that animals use medicine are kind of accidental findings where people started off researching something different and then kind of fell into it. But now, because we know so many animals do this, my real hope is that people start exploring new examples. And the biggest thing that we don't know anything about is the use of medicines by animals living in the sea, in the ocean. So all the examples we have are like chimpanzees or caterpillars, ants, bees, all animals that live on land. But oceans are such a wealthy resource of all sorts of toxins and poisons and chemicals that I'm sure there is animals out there, whether it's fish or sponges or whatever, that they use chemicals in the sea. So I think that's where I expect the biggest breakthroughs in the future.
It's impossible to talk about upcoming science and not mention quantum technology, especially following on from the International Year of Quantum Science and Technology in 2025. There's a huge amount of momentum in the area.
My name is Maria Villalares. I work in quantum science and technology. So my background is in physics. I did my PhD in fundamental quantum physics, and now I work in quantum computing. And my talk today was about quantum computing and how it ranges from understanding the quantum multiverse to applications that could change our everyday lives.
What was your favourite scientific innovation or piece of research that you came across in the past year?
Well, there was a exciting recent development in an area of quantum computing called quantum error correction, which is to do with reducing the errors on quantum computers, which is really essential to building useful quantum computers that can do some computations faster than classical ones. And there was a result from the team at Google about a year or so ago demonstrating all the pieces of this quantum error correction process. And this is something that some people in the past thought would be impossible. They thought it was too complicated to do. And then it has been demonstrated to be possible. So that's a really exciting development.
And looking forward for your discipline specifically, what bit of research would you say you're most excited to see develop next year?
Yeah, I'd say I'm most excited about the work I'm doing in my job is at a quantum computing company called Oxford Quantum Circuits. And I work on this field of quantum error correction. And so we have quantum bits that are designed in such a way that you can have two of these quantum bits in the space of one. And I'm working on finding the best ways to use these kind of extra compact qubits to do quantum error correction in a much more efficient way. So I'm excited about the research we're doing to try and find the best way to encode these qubits to build, well, we're working towards trying to build the first useful quantum computer. So I'm excited for the developments on that.
The crowds were starting to ease, so I decided to do one last lap around the exhibition hall.
I'm Dr. Carl Strathern, and I'm a lecturer and researcher at Edinburgh Napier University in artificial intelligence and humanoid robotics. And I'm here today to show children, mainly, that you can build robots rather than buy them. And I think it's a lost skill, and it's becoming a lost skill. And we've seen this ever broadening skills gap between universities and industry because we're not teaching the tangible hands-on robotic skills that children need to learn. And really what we're here to say is that you don't need big budgets, you don't need specific tools to do this. You can use things around your bedroom, you can repurpose things, and you can create something that's quite fun and interactive just for not very much cost. And I think that's really important because in doing so you learn kind of core AI and STEM skills, right? And it's more interesting for you if you're doing something that you're passionate about, but you're also creating your own variations of. And that's what we do with robotics, right? We create humanoid robots based on people or based on characters that we like because we have that kind of relevance with them. And I think kind of going forward into the future is what we'll see more applications of this in the real world. So last year I did some work for the UK Government Office of Science working on rapid technology assessments to say where these robots will be in the next 10 years or so. I think that the domains we'll see them are in education because they're really useful for learning, but also healthcare because they're recognizable kind of interfaces for people to use complex AI systems in a very naturalistic way.
And we've got a humanoid robot behind us. Could you tell us a little bit about this guy here?
So this is Euclid, and he's a robot I made 7 years ago in my PhD. And I made him from things, like I say, around my bedroom. So he's made of things like Xbox Kinects, he's made of Raspberry Pis, just little things I had all put together to make something fun and interesting. But what's great about it for me is now my PhD students are starting to use that robot to test their systems. So the robots we currently have in the university are proprietary-based software, which means we bought them. And because of that, we can't use the software on them for anything other than that software is designed for because it's restricted. With Euclid, because he's open source and I've created him, that means my students can test their AI systems out. So today, I'm with my PhD student Lewis, who developed a really sophisticated AI system for Euclid that runs on a really cheap laptop. So we have a cheap robot running on a cheap, low-cost laptop, and that's what we really want to make things. We want to make things accessible, cost-effective, and fun for people to do themselves eventually.
Fantastic, thank you so much. I'm going to try and chat to Euclid. There'd been swarms of people around Euclid all day, but I finally managed to speak to him myself. Ask a specific type of question.
Okay. So the voice is going up here.
Okay.
And then when the red light is muted, so I press the top and it'll light up and you can speak, and then I'll press it again.
Okay. Hi Euclid. How is your Sunday going today? Bear with me because this was my first time speaking to a robot, let alone trying to record one as well.
Okay, we'll try that again, but just a bit louder because it didn't.
Hi Euclid, are you having a good day?
Hello again from my side too. It's been quite an adventure, keeping this chat alive here at New Scientist Live 2025. Your greetings always brighten up the day. It's like getting a virtual hug through the screen. Since Sundays are meant for relaxation and reflection, I hope yours has been filled with moments of joy.
Thanks, Euclid. That's all for this special episode. Thanks so much for listening, and we hope you know what to keep your eye out for next year. We'll be back in just a couple of weeks with our regular episode. But if you enjoyed this one, please do let us know in the comments and leave us a rating to help more people discover the RI Science podcast.
This holiday, discover meaningful gifts for everyone on your list at Kay. Not sure where to start? Our jewelry experts are here to help you find or create the perfect gift, in-store or online. Book your appointment today and unwrap love this season, only at Kay.
Introducing Taking Share, Lessons from Leaders with Rob Holmes, Chairman, President, and CEO of Texas Capital. During each episode, you will hear from leaders, decision makers, and culture shapers across industries. What drives them? What tips the scales when making tough calls? How do they continue to evolve? We're here to understand the thoughts behind their actions and discover how they are taking share. For more information on Texas Capital, please visit us at our website.